Assalamu alaikum wa rahmatullahi wa barakatuhu. Hi everybody and viewers. My presentation goal is to help you in learning basic physics in F.Sc. If you follow me, then inshallah one day you will be a master in physics and even can be a scholar. In today's lesson, we will solve MCQs and conceptual questions of chapter number 11, electrostatics. Now let us come to the question number 1. Now let us come to the first question. A charge capital Q is divided into two parts, small q and capital Q minus q, and separated by a distance r. The Coulomb's force of repulsion is maximum when it means that they have given us that force of repulsion between the two parts is a maximum, and these four options are given. They ask us to take the correct one. Now the condition is that force is maximum. It means that charge upper 1 divided by charge upper 2 must be equals to 1. This will mean that the force is maximum. Now putting these values of the charges, small q divided by capital Q minus q equals to 1. Now after cross multiplication we get small q equals to capital Q minus q, and this minus q is taken to the other side, so on this side we have 2 q's. Their sum will be 2q, so capital Q equals to 2q. Now divide both sides by 2 and we get small q equals to q by capital Q by 2. This option is the correct one, and now we will see and check whether this option exists in the given options or absent. So this option is option number C. Thus option number C is correct. Now let us come to the second objective. Three objects A, B, C are brought together, two at a time. When A and B are brought together, they attract. When B and C are brought together, they repel. What is the conclusion? So four conclusions they have given us: A, B, C, and D. Now A and C possess same signs of the charges. B option, A and C possess charges of opposite signs. It's option C, A, B and C possess same signs of the charges, while in option D, A or B or C is neutral. One of the three objects is neutral. So this can be shown by two ways. That which option is the correct one according to the given first statement, that A and B are brought together and they attract. Attract means that both the bodies have opposite charges. Is A is plus, B is minus, and this in the second statement says that B and C are brought together, they will repel. Repel means that both the bodies will have the same charges, signs of the charges. It means that they will repel. So from this we conclude that object A and C have opposite charges, which is present at option number B. This option B is correct. In the second way we can also show this, that option B is correct. Second way is that in the first statement say that A and B are brought together, they will attract. It means that opposite signs are here. Here we have taken positive charge for A and negative sign for B, but here we have taken negative for A and positive for B. In the second statement they say that B and C are brought together and they repel. Repel means that they have same signs of the charges. Here in the upper way we see that B is negative, C is negative, both repel. Here we took B is positive, C is also positive, it means that they will repel. So here again we conclude we conclude that A and C have opposite signs. This also shows that option B is the correct one. Now let us come to the question number 3. Object A of charge whose charge is plus 2 microcoulomb, and object B whose charge is plus 6 microcoulomb. Which statement is correct? Here 4 options are given, but see towards nature of the question that there are 2 charged objects and they exert forces on each other. So the forces, they act on each other. So those forces will be action and reaction forces. It means third law will be obeyed. So here A option is wrong, C is wrong, D is wrong. It means that option B is correct, because FAB equals to minus FBA means that the magnitudes of the two forces, action and reactions, are equal, but they are opposite in directions. Question number 4. Some charge is given to a conductor its potential. It means that some charge is given to a conductor, and tell about the potential of the conductor. 4 options are given, and we will see. We see that on the surface the charge accumulates on the surface of the conductor, while inner side is empty of the charges. So on the surface potential, electric potential will be kq by r. We have taken A and B, any 2 points inside the conductor. 8 point A potential inside the conductor, potential would be kq by r, and 8 point B inside, potential will be kq by r. And also if we want to find the value of the electric potential at the center of the conductor, this will also come out to be Vc equals to kq by r. From all these equations, we see that the values are same: kq by r, kq by r, kq by r, kq by r. It means that electric potential on the surface and inside the surface, anywhere, even at the center, the potential, electric potential, will remain same. So 4 options are given, but option C is correct. Same electric potential will be same throughout the conductor. Now come to the question number 15. The unit of electric field intensity. The question is asking that which one is the unit for the electric field intensity. Option A, B, C, and D. So we see that volt per meter is the unit of electric field intensity. Newton per coulomb is also the unit of electric field intensity, but here Newton was a scientist and his name should not be written. Actually, his name should be written in small letters, but here N is written in the capital form. So this option is wrong. Similarly, C option is also wrong, because Joule was also a scientist and the unit should be small n. The unit should be in small letters, small Joule, and per coulomb meter. Similarly, this option C is also wrong. Now come to the option number 4. So voltmeter is the unit of electric flux, not the unit of electric field intensity. Thus the correct option is option A. Now come to the question number 6. Proton is about 1840 times heavier than an electron. It is accelerated by a potential difference of 1 kilovolt. Its kinetic energy. It means that battery is applied to a conductor where free electrons exist, and the free electrons will be accelerated by the battery. The battery has its electrical potential energy and will be given to the electrons in the conductor. Electrons in the conductor, but here, sorry, they are asking about proton. They are asking about proton, that what will be the kinetic energy of proton. So four options are given. The same will be the situation, but here the voltage of the battery will accelerate proton, so electrical potential energy will be converted into kinetic energy of the protons. For equation will be del Ke equals to QV. Now QV is the change of proton, while V is the accelerating voltage given is 1 kilovolt. Kinetic energy will be equals to, now put the values. Q is given per proton, which is 1 E. Voltage given is which is 1 kilovolt. 1 kilo electron volt will be the kinetic energy of proton when 1 kilovolt voltage is applied to the protons to accelerate them. Thus, the option C is correct. Question number 7. The electric field at a distance 20 some from 2 microcoulomb charges. Here the electric field is required to be found out. Here four options are given, and units given are the units of electric field intensity. So we will apply equation of the electric field intensity of a point charge, E equals to kq by r square. Putting the values here, finally we will get 4.5 10 power 5 Newton per coulomb. The answer for the electric field intensity, we see this option is 8. Number 4, that is D, so option D is correct. Question number 8. An electric charge Q is placed at the center of a cube of side A. The electric flux through its one side. Four options are given. Now we will see how many flux will pass through one side of the cubic body. So Gauss's law equation is applied. Total flux through a cross surface equals to 1 over epsilon naught into Q. And cube, we know that consists of 6 faces, 6 planes. So electric flux through one surface of plane will be pi 1 equals to 1 into q by 6 epsilon naught. So total surfaces are 6, the total flux is divided by 6, and then we are finding electric flux through one surface, one plane, one face of the cubic structure. So therefore 1 is multiplied here. The flux through one surface will be q by 6 epsilon naught. If we want to find electric flux through two surfaces, so pi 2 will be equals to 1 is replaced now by 2, and 2 q divided by 6 epsilon naught. So 2 and 6 can simplify, and we get the answer for two surfaces as q by 3 epsilon naught. Similarly for three surfaces, and answer will be this for 6 surfaces, which will mean that we have to find the total flux through the total surface of the cube. So here total flux will be 6 q divided by 6 epsilon naught, and total flux through the whole surface of the cubic body will be q by epsilon naught. Here I have given you a technique that if they ask two surfaces, three surfaces, 4, 5, 6, or any surfaces, so you can find the total number of flux through that surface or those surfaces by using this technique. Now let us came to the options, they want and they ask electric flux through one side of the structure, so structure cubic structure. So for one side the electric flux would be q by 6 epsilon naught, and that option exists at option number A. Option A is correct. Now let us come to question number 9. The electric flux through the surface of a sphere charge cure is enclosed depends it. This question means that we have a sphere closed surface enclosing charge cure, so they ask that they find the electric flux where it will depend upon. So here four options are given: radius, charge outside, surface area, and charge inside. So according to Gauss's law, the enclosed charge is divided by the permittivity, and that will be a total flux. But here the A, B, C options are wrong, and option number D is correct, because charge inside is related with the total flux emitting from the closed surface. Now let's come to question number 10. 1 microfarad capacitor of TV. 1 microfarad capacitor of TV is subjected 4000 volt energy stored will be here four options given are. Now you see that here is the capacitance and second given in the data is 4000 volt electric potential. So there are four formulas, equations for the electrical energy stored in a capacitor, but this formula fits for the givens and for the required. So U equals to half CV square. C is given, V is given. Therefore, putting the values, we get 8 joule of electrical energy stored in the capacitor, 1 microfarad capacitor. Thus, option option A is correct. Question number 11. In the figure below, charge on 3 microfarad capacitor is to be determined. So 4 options are given. Now see towards the figure. All the 3 capacitors are connected, and or the 3 capacitors connected in series with the external battery of 10 volts. So in series combination of resistors, we use the formula 1 over C equals to 1 over C1 plus 1 over C2 plus 1 over C3. Putting the values here and simplifying, we get 1 over C equals to 1, and inverting both sides, we get C equals to 1 microfarad. Now in series case, charge is same for all the capacitors from the battery. From the battery, the charge supplying is same for all the 3 capacitors. So we use the formula Q equals to CEV, the charge which is supplying by the battery. Here CE we found as 1 microfarad, and V voltage is given, which is 10 volt. Thus 10 microcoulomb is the charge passing through C1, C2, C3. So the answer for this 3 microfarad capacitor is the 10 microcoulomb charge will pass through the capacitor of 3 microfarad capacitance. So option B is correct. Now question number 12. Two parallel metal plates are 8 meters apart. Electric field is uniform, directed towards right, and has a magnitude 4 Newton per coulomb. If an ion plus 2E is released at rest at the left hand plate, then what will be its kinetic energy on reaching the right plate? Here this ion is released here near the positive plate, and it will accelerate towards negative plate B. So reaching there, we will try to find its kinetic energy. We will apply the equation del K equals to QV. Here Q is the charge of the ion, which is plus 2E, and VV is equals to ED. And now putting the values, Q is replaced by 2E, electric field intensity 4 Newton per coulomb, 4 Newton per coulomb, and the separation of the plates is 8. Now multiplying these, and finally we will get 64 electron volt, which is the kinetic energy gained by the ion on reaching the right plate. So option B is correct. Now question number 13. Question number 13. Electric potential between 2 points A and B is delta V. Work done by the field moving the charge Q from A to B is we have to find the work done in moving a charge from one plate from plate A towards plate B. 4 options are given. One of them will be correct. Now work done on charge Q and moving from B towards plate A by the force F equals to QE is W equals to Q del V. Here how this work comes out to be. So we know that we have read this formula, that W equals to FD. This formula we have been read in class 9th and class 11th, the W equals to FD. And so here F is replaced by QE D. It means that QED, but here the product E and D equals to potential difference, thus WE becomes equals to Q delta V. Positive work is done. Now to move the charge back from A to B, we have to find that work done. So for this work done, to move the charge from A to B, force acting is my F equals to minus Q delta Q minus QE. Hence work done will be W equals to minus Q delta V. How this equation comes out, W equals to FD, force is F equals to minus QE, and now minus QED. Here the product E and D equals to potential difference. Thus this is the work done in moving the charge from plate A towards plate B. That's enough. I think all of you would have learned a lot, and inshallah next time I will try my best to give you and to learn you a lot more. So my presentation goal is to help you in understanding the basic physics and F.Sc, and all of you are requested to follow me, and then inshallah one day will reach that all of you would become masters in physics and even scholars. Thank you, but before thank you, you all should subscribe and also share the video. Thank you.